Hello again and welcome to the 20th episode of Simply Electronics Basics. Today, we're going to take a look at series and parallel capacitors and the basic differences between how they work in both configurations. First of all, if you have seen this video, you will find that the outcome of series and parallel capacitors are the exact opposite of series and parallel resistors. If you haven't seen this video, I'll leave the link in the description. So let's first have a look at how capacitors work in parallel configuration. On the screen is the most simple circuit I can make to demonstrate parallel capacitors. I've basically got a 3-volt power supply and an LED which requires 3 volts at 20 milliamps, and I've got capacitors in parallel. I also have a switch on the circuit, meaning I can turn the circuit on and off. When the switch is closed, these capacitors charge up to the 3 volts and this LED gets powered. When I open this switch, breaking this DC power supply, the capacitors will continue to provide current to the LED until the voltage of the capacitors is below the running voltage of the LED. So let's have a look. As you can see, the LED slowly fades out. Now, these capacitors are 100 microfarad capacitors. This is the capacitance rating of each capacitor. Because these capacitors are in a parallel configuration like this, the total capacitance is simply the sum of the capacitance of each capacitor. In this case, the total capacitance in this parallel configuration is 100 microfarads plus 100 microfarads. The total capacitance here is 200 microfarads. So I've just changed the value of these capacitors. You may pause the video to see if you can work out the total capacitance in this parallel configuration. If you didn't pause the video, the answer, of course, is 100 microfarads plus 500 microfarads, giving us an answer of 600 microfarads. Okay, now let's have a look at capacitors in a series configuration. You can see here I have exactly the same circuit as below, with the power source and the switch and the LED, but this time I actually have the capacitors across the LED in a series configuration, rather than the parallel configuration on this circuit. So in this case, can you guess what the total capacitance is in this circuit? Well, it is exactly the opposite to what we would expect with series resistors. With these capacitors in series, the total capacitance in this case, because they are both equal, is halved. So the actual capacitance of this series capacitor configuration is 50 microfarads. But just in case there are different values of capacitors that aren't exactly the same, there is a very easy equation which is exactly the same equation used to work out parallel resistances. So the equation in this case is 1 over C1 plus 1 over C2 and so on and so on. But we've just got the two capacitors. So in this case, the total capacitance here in this series configuration is equal to 1 over C1 plus 1 over C2. So in this case, we use the equation as follows: 1 over 100 plus 1 over 400, which gives us an answer of 80, or a total capacitance of 80 microfarads. So even though we're using higher value capacitors here, because they are in a series configuration, the capacitance is actually much lower, and we can demonstrate this visually. Let's turn both circuits on. Given that the above circuit has less capacitance, this means that the LED should fade much faster than the bottom circuit. So let's have a look. So that faded pretty quickly. Let's have a look at the bottom circuit. You can see there is a clear difference in the time it took for the LED to fade. Now, if you didn't quite get there, I've left a couple of links in the description for you to have a look at after this video. Plus, you can also interact with this live circuit by clicking the link in the description. Look forward to more videos on capacitors and more videos on everything else as well, so make sure you subscribe to this channel, give the video a thumbs up if you enjoyed it, and I'll see you in the next video.